So for this rational function, we want to find and label all asymptotes, find the domain, the x and y intercepts, and then come up with the graph. So the first thing we typically would want to do is factor the numerator and the denominator. Well, the numerator cannot factor that. The denominator is going to be x, let's see, it'll be x minus 4, x plus 1. So what that tells us is those factors cancel and we're left with 1 over x minus 4. Because those factors cancel, that means we have a hole in the graph at x equals -1. In other words, if I input -1 into the graph, I get something that's undefined, because that would make the denominator 0. And so that means the graph doesn't actually have a value at x equals -1, which gives us the 0, or the hole. So let's find the asymptotes. For the horizontal asymptote, we look at the degree of the numerator and the denominator. The degree of the numerator is 1, because it's x to the x to the first, and then the denominator is x squared. So the numerator of the top is less than the numerator on the bottom. That tells us we have a horizontal asymptote at y equals 0. For the vertical asymptote is any unique factors, or rather any unique zeros of just the denominator. And by unique, that just means any zeros that are left over after any canceling has happened. So the only factor that remains in the denominator is x minus 4. So the 0 of the denominator is going to be 4. So that tells us we have a vertical asymptote at x equals 4. We don't have an asymptote at x equals -1 because that factor is not unique. It cancels with the same factor in the numerator. What else? We want to find the domain. So the domain is all values that we are allowed to put into the function. So we are not allowed to put values into the function that makes the denominator 0. So the values that would make the denominator 0 are 4 and -1. So if we look at this on the number line, 4, -1, well, I'm not going to have values there. I cannot input those. So I'm going to have all of the values where we're shaded. So looking at this in interval notation, we're going to say -infinity to -1, union, -1 to 4, union, 4 to infinity. That would be the domain. The x-intercept is, well, what values make the numerator equal to 0? Well, the numerator is x plus 1 equals 0. So -1 would make the numerator 0, but looking at the domain, I cannot actually use -1. -1 is not in the domain for this function. So -1 would make the numerator 0, but -1 is not in the domain. So there's no x-intercept. There's no possible value that makes the numerator 0. For the y-intercept, what we do is we evaluate f at 0. So plugging in 0, we're going to get -1/4. So the y-intercept is 0, comma, -1/4. So putting all of this information together, the graph is going to look like this. We have a vertical asymptote, or a horizontal asymptote at y equals 0, vertical asymptote at x equals 4. There's the vertical asymptote. We have a horizontal asymptote at y equals 0. We have no x-intercept. We have a y-intercept at 0, comma, -1/4. So 0, comma, -1/4 is something like that. So we know the graph is going to be below in this bottom left section. It's going to cross that y-intercept. And then we have a hole in the graph at x equals -1. So at -1, we have the hole in the graph, and then the graph continues to get close to that horizontal asymptote. And then we need to figure out whether the graph is in this section or down in this section. There's no graph up here because if there was, for example, if we thought something like that was going to occur, well, that doesn't pass the horizontal line test. So that would not be a function. So we know there's no part of the graph up there in that top left section. So what we want to do is take a point, how about x equals 5, and input it into the function. So inputting that into the function, I get f of 5 equals 5 plus 1 over 5 squared minus 3 times 5 minus 4. And we get 6 over 25 minus 15 is 10. 10 minus 4 is 6. So that's 1. So what that tells us is at 5 we have a value at 1. And that's all we need. We just need to know where the graph is. So because we're above, the graph is going to look like that.